I don't have a sheet like you guys do because of the fact that I did notes on the iPad. And I can't record on the iPad. So, I'm starting up on a blank sheet of paper for the sixth type of factoring that we're talking about today. So, we went through and we talked about things like, generally, first thing you should always do when factoring is start with the greatest common factor. After you do GCF, you check for further factoring. If it is a trinomial, in other words, it's got 3 parts, you've got like the AC method or its shortcut. If it's got 4 parts, we've got factoring by grouping. And then we talked about difference of squares. If it's only got 2 parts, it could be a difference of perfect squares. Today, we're going to talk about the sum or difference of cubes. What does it mean to cube something in math?
3.
Put it to the 3rd power. So, sum or difference of cubes.
I'm technically right.
Has to be a perfect cube. And in this case, it can be either adding or subtracting. Sum of perfect squares does nothing. But the sum of perfect cubes does factor just like the difference of perfect cubes. But it has to be perfect cubes on both terms. This is a binomial situation again. Both terms have to be perfect cubes. Why did I put parentheses there? Don't put a parenthesis there. That was dumb. So, let's say I've got a cubed plus b cubed. Now remember, a and b, similar to difference of squares, is the placeholder for both numbers and variables. It can be made up of both. But if I have a perfect cube plus a perfect cube, it will factor into double parentheses. But the first one's a binomial and the second one's a trinomial. The binomial is a plus b, where a and b are the things that got cubed. And then the trinomial is a squared minus ab plus b squared. So whatever got cubed originally gets squared, minus whatever both of the things that got cubed originally multiply together, negative in front, and then the second thing that got cubed originally gets squared. The difference of perfect cubes looks very similar. Instead of a plus b in the first parenthesis, it's a minus b. Instead of minus ab, it's plus ab. If you do not have these formulas written down, you're going to have a hard time factoring difference of cubes. So write this down. Even if you are not a person who takes a lot of notes, write these down.
I think you should write it down.
Yeah, I think we should write it down.
I wasn't looking at you in the first place, Nathan.
No, it looked like it.
Okay. Now, with this one, let's just have a quick chat about our perfect cubes. Generally, there are people who have some inkling of their perfect squares. Does everyone? No. But there's some inkling of what a perfect square is. Perfect cubes, we don't tend to talk about a whole lot. So, let's talk about the basic perfect cubes. So I'm going to give us a little chart of our perfect cubes. In that little chart, I've got n's and I've got n cubes. So, n's, in other words, it's the thing that you're cubing. 1 cubed is 1. 2 cubed. What does it mean to cube something, by the way? Multiply by itself 3 times. 2 times 2 times 2 happens to be 8. 3 cubed is 27. 4 cubed is 64. Now, if you have no earthly idea what the perfect cubes are, could you find them on your calculator? Yes, you just start taking numbers and putting them to the power of 3. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. Ooh, I'm going to run myself out of room. I wanted to go all the way up to 10. 9 cubed is 729, and 10 cubed is 1,000. The 7th form of factoring we're not going to talk about today. You should have a little bit of extra space here. That is for what we're doing tomorrow. We are going to skip down to where we are doing examples. What did we leave off? On example like E? We're on E. We're on F. I legitimately didn't know exactly where we were. So, here I'm just going to pick up off at the end of where you were for examples. I don't know exactly where you were. Because again, I don't have this. The instructions were still factor completely. Seven x cubed plus 56. First thing you should do is GCF. What's the greatest common factor of 7x cubed and 56? 7. I'm left with x cubed plus 8. Now, when I do the sum and the difference of perfect cubes, this is where more issues pop out just because of people making little mistakes. One of the things that you will find that I tend to do is I tend to say, okay, if this is x cubed, and I know that to be a cubed, what actually got cubed to get me x cubed? Now, x is really, really easy. What do you cube to get x cubed? X. That means the a in my format of sum or difference of cubed is just x. What got cubed to get me 8?
2.
8 is 2 cubed. So the b in my format is 2. Now, is this a sum or a difference of perfect cubes? Am I adding or subtracting, in other words? Adding. Is adding a sum or a difference? Sum. Uh-oh, I screwed up. I wrote the wrong thing down. Specifically this right here. When you are factoring sum and difference of cubes, there will always be a minus sign somewhere. A difference has the minus sign here. A sum has the minus sign here. Okay. Now, this tends to mess with people more than anything, the a squared and the b squared. So that tends to be always what I do first. If a is x, a squared is x getting squared. Now on this one, that's pretty easy. If I square x, I get x squared. B squared is 2 getting squared. And this one also doesn't tend to be bad. 2 squared is 4. Now I'm also going to have to do a times b. So while I'm at it, AB, in other words, a times b is x times 2. What's x times 2? 2x. So, those are all the key components. I tend to write the key components when factoring separately because I found that that helps people. Do I do it personally when I'm factoring on my own? No. Okay. Parentheses start a plus b. A was x plus b was 2. Parentheses. Then it says a squared, which we calculated to be x squared. Then it says minus a times b. A times b was 2x plus b squared plus 4. Don't forget to put the GCF back out front. Do you notice that there are exponents left over? Generally, when there's more exponents, what do you have to do?
Factoring.
Check for further factoring. Here's the nice thing. A difference of squares will never factor further. It will be impossible for it to factor further. Sorry, a sum or a difference of cubes is what I meant to say. It is impossible for them to factor further because you're never going to find something that multiplies to b squared but adds to ab. It just doesn't work. So, this is the final factored form. Okay, first example. Feeling okay with it? The second example is going to be probably what trips people up more. So, if you are a person who tends to pay attention to one example and then ignore me, I advise not to do that. I am factoring. The first thing I should always do when factoring is GCF. What's the greatest common factor here? It's not obvious, is it?
What? 25.
Okay. It's not obvious what would divide out, so I look at the smaller term.
Nick, you're the smartest guy I know about.
I start with its biggest factors. What's the biggest thing that... What's the biggest thing that could divide out of 24? 24. No. What's smaller? 12? No. Smaller?
6.
8?
Oh yeah, that's fair.
No. Smaller? 6?
Try 7.
No. 24 doesn't divide by 7. 4? No. 3?
Yep, 3.
So, when in doubt, just think about all of your things that multiply to get you your number and just start going through them. You'll eventually find one if one exists. But if I said 3 is not the GCF, could you tell me why?
Because it has X.
Because they both have x's, which means I can also factor out x. Seriously, guys. I don't care who started it. Okay. Do you notice 2 terms? Yes, no, maybe? Binomial? Next thing I notice is cubed.
Yes.
Makes me think either a sum or a difference of cubes. Would it be a sum or would it be a difference?
Difference.
It would be a difference. To make that happen, this would have to be a perfect cube. Is there something cubed that would give me 8x cubed? 2x. Is this a perfect cube?
Yes.
Yeah.
What gets cubed?
5.
5. The negative is the in-between. You only look at the digits for what got cubed. Though, that is something valid to pay attention to. Okay. So, why did I put a parenthesis there? Dumb. I keep putting extra parentheses. Don't mind me. So, a cubed minus b cubed. Again, the format of that was a minus b. A squared plus ab plus b squared. What's a? All of 2x. What's b? 5. Now, here's what messes with people. What's a squared?
4 squared. 4x squared.
Yes, because you need to square that entire thing. It is 4x squared. B squared?
25.
5 squared is 25. I also need a times b. 2x times 5? 10x. That's all my components. I can now go to my factored form. First thing I notice is a minus b. What's a? 2x. What was b? So 2x minus 5. Second parentheses starts a squared. We calculated that already. It was 4x squared. Then it says to do plus a times b. 10x. Then it says to do plus b squared. 25. Be careful that you're grabbing the correct things. Before I call this done, bring your GCF back out front. Now, I notice x squared, which makes me think maybe it factors further, but the nice thing about sum and difference of squares, it never will. Sorry, let me try that again. Sum and difference of cubes, never will. Now, there are some very, very, very common errors that I see that people need to be careful of. I've got 2 more examples. They address the common errors. Yeah, all 4 of them.
I know. I'm running out of space on my page, Benson.
Bro, I don't want
Well, it can go on to the next page.
No, I don't want to use 3 pages for one thing.
How big are you writing?
What did you think I was going over there for?
Blocks of doom and despair and all unfair.
Oh, no.
Evelyn, where should I start on this problem? What is the greatest common factor here? 5x squared. Mina, if I factor out 5x squared, what am I left with?
X squared minus 36.
Perfect. Okay, so I gotta check if I can factor further. Binomial. What's different about this than the previous problem?
There's no cubes.
It's not cubed, it's squared. So are we looking at sum or difference of perfect cubes? No. Could we be looking at a sum or a difference of perfect squares? Is it a sum or a difference? Difference. If it was a sum, would it factor further? Nope. No, sum of different squares does not factor. Sum of squares, sorry. Difference of squares does. Difference of squares was the one that was this, and it goes a plus b, a minus b. What's a?
X.
What's b?
36. Oh, 6.
6 got squared, and it is a difference.
Good going now.
So, Kaylin, what's the factored form going to look like? So it says a plus b. This was a, this was b. So a is x, b is 6. Kaylin, can you help me out with the second half of it then? A was x, b was 6.
So then
X minus 6. Carter, is that the final answer? Don't forget to put the 5x squared in front. Okay, my point of this is one of the most common mistakes I see is after I introduce sum and difference of perfect cubes, people assume everything is sum and difference of perfect cubes. Keep an eye on it. This one was squared. Final example.
Can you use a whole page?
Then don't.
Question?
Well, like I need the notes.
Red smaller.
Try.
Right off to the side.
Just use the whole page for the one problem because you're writing in size 80 font, it seems.
Moving on. Layla, where should I start? Dividing? Finding the biggest thing that divides out of everything? Perfect. If this is just a number 1, what's going to divide off of everything? 1. We check it. But it's got to be 1 here, so we move on. Okay. Shay. Is this looking like a sum or a difference of cubes or a sum or a difference of squares? Looks like it's looking like a difference of cube because I see x cubed. That's my setup. Peyton, what cubed will give me 343x cubed? Peyton, did you write down the chart? Don't get me wrong, you can use your calculator and go through the things, but I gave you guys the chart for a reason. But is it just 7? Perfect. Jaden, what about here? Just 1. For some reason, people tend to overlook 1 as a perfect square or a perfect cube. It is both.
One is
Cool like that, I guess.
itself.
A lot,
Or
yeah.
what you do to it exponentially.
Okay.
Oh, dude.
One is one.
It's reflexive, actually.
I don't know what that means. Too many syllables.
When it's a difference of perfect cubes, inside the first parentheses is a plus or a minus. That's where the minus shows up. Everything else is plus signs.
What kind of space here now?
Bella, what would be A?
7x.
Beckham, what would be B?
-1 or 1.
Just the 1. Matthew, what's A squared?
49x squared.
How'd you get 49?
7 squared.
Yes, because that entire thing's getting squared, which means you squared both pieces. Sir, what's B squared?
The space. Oh
1.
Question of doom and despair.
Connor, what's AB?
I wonder.
Just 7x, because it's 7x times 1. Ryan, in its factored form, what's going to go in the first set of parentheses?
7x minus 1.
Beautiful. Aiden, what goes in the second set of parentheses? Be careful. You got to square that 7. Hence, we wrote this here, not 7x squared, but 49x squared. Okay, keep going, Aiden.
It's not 7x times 4.
So plus 7x. Good. And then the last thing? Plus 1. Mitchell,
What's up?
should I check for further factoring?
Nah.
Why not?
Because sum or difference of cubes.
Which means it will never factor further.
Yep.
Okay. Your assignment's on page 680, or 180 again. Please do make sure you're writing page 180, day 2 on the top of it.